All right, we are live. Hello, everybody, and welcome to Turbonomics Labs. This is going to be a fun show today. We're going to be doing a little bit of a race against time, featuring some really, really cool infrastructure as code work. So hold on to your hats because this one's going to be a fun one. We're going to go end to end on building a fully automated AWS Elastic Kubernetes Service lab. So let's get started with where we're going to go. My name is Eric Wright. If you haven't already seen us before, welcome to the stream. So I'm the tech evangelist here at Turbonomic, and today is going to be our Open Tech Thursday. So every Tuesday, if you do want to check it out, you can always go to turbonomic.com/labs. We've got our link to the office hours there, which is what this is. You can also go to the YouTube page and you can see all of these on demand. So you go to youtube.com/turbonomic, and you can always get access to these after the fact. And of course, because we are live and we're having fun with it, I'm also able to take comments. So for folks that are able to interact with us, whether you're watching us on LinkedIn Live, on Periscope, or right live on YouTube, if you pop in a comment, it's going to show up over here, and I'll be able to take any questions and capture the Q&A on the fly. So with that, I'm going to actually, because I didn't want to start with the Martha Stewart pre-baked oven, we're actually going to start this right live right now, and then we're going to start working against time to see how it all works. So I'm going to kick this off here. We're going to say Turbonomic Labs launch. Okay. So I think that's the best place to begin. Let's talk about what this is and what you're about to see happen in action, fully automated, live. So literally, I just did everything I'm going to need to do. And in just about 20 to 30 minutes, depending on how fast the AWS infrastructure is, we're going to have ourselves a fully functional end-to-end live EKS lab. And I literally did nothing. And I'm going to show you how you can do the same thing because this is fully open source code. So let's begin there. All right. So what are we using to make this lab? I'm going to jump over to the GitHub and we're going to sift through. We'll start with the README because we've documented as much as we can. And also, if you want to find out more about this, I'm going to be publishing a white paper ebook, I guess you would say, which is going to have all of the code, a full deep explanation of exactly how we're doing this and really kind of why it's important. And I know a lot of folks are going to say, hey, wait a second. EKS is super easy. Well, it's actually not, because if you're starting from scratch and you want to set up a brand new EKS environment, ideally, there's a few things you should have in place. So you can start by going to github.com/Turbonomic Labs, and there's a Terraform EKS Lab. We're going to be using effectively three components in what we're doing right now. One is, of course, GitHub, the place where we store the code. So this is going to be a version control backed repository. And then we're going to trigger and run the infrastructure as code solution being Terraform. I'm using Terraform Cloud so that I can actually collaborate and have a shared access to it. And then we can do our secrets management and other things in there. So free. Okay, part 3, not free, however, much more inexpensive, because if I wanted to spin up an EKS lab and I was worried about what it takes, setting it up, remembering to tear it down, it costs you it's a not insignificant amount of money if you leave that lab running all the time. But sometimes I literally just want to spin it up, test out a bunch of application deployments for deployment patterns, and then from there I want to rip it down because I don't want to keep paying for that. But we leave behind stuff and we forget where it is. We know that this is an unfortunate habit. So this is not only a lab that stands itself up, but then it tears itself down at the end with one click. So that's pretty cool. So we're looking at the code here. This is on the GitHub page. It's in the README. So if you actually fork this repo, which I would recommend, so that's how we're going to do things. If you want to contribute back, this will be a thing in motion for a little while, but it's fully baked and ready to go. So it works today from end to end. We've got, I call it the Terraform AWS EKS Lab. It's meant to be a ground up, or cloud up in this case, infrastructure setup. And the reason why I wanted to do this is because there's a few different things that are required for EKS to actually work. And we actually recently did an EKS build from the ground up on Turbonomic Labs. We've also done VPCs from the ground up. So you actually can see all the different bits that make up how to do a public and private VPC. And those were half-hour, 45-minute sessions to just talk about it and to walk through it. So imagine that I can get that down to one click. You have two requirements you're going to have here, which we tell you right there. You need a Terraform Cloud account, which is completely free. Or if you've got Terraform Enterprise as well, you can use that. Works the same way. You need some IAM credentials. Now I'm going a little bit heavy-handed on here because I'm going to use I've got a higher level, like I'm actually using some admin credentials. Ideally, what we'll do is we'll post the IAM requirements in order to spin this up as well. But today we need a bit more advanced privileges, but I'll identify that as we go. So what's actually in this lab? And let's just zoom in and take a look. Oops. So what we need to do is we need to create our IAM. So the first thing we want to do is we want to create new roles specifically for this. And why I want to do this inside the lab is I don't want it to be something that I leave behind. Number one, like how many times have you seen like security groups that are named like default launch security group, number 28, right? So I don't want to have something that I leave. I want to label it, tag it, and then get rid of it when I'm done. Because I don't want to go in 6 months and say, is this still a working IAM credential and role? So we're going to set up the roles for EKS and for EC2. We're going to set up a brand new VPC. So again, this is free. We're going to set up 3 public subnets and 3 private subnets. So this allows you to have both private side and public side access. We're actually going to probably do more variations on this, but it's easy to do now because we've fully automated and scripted this entire deployment. We're going to create the security groups, add ingress and egress. It's also going to be driven by code, which we'll show you in a couple minutes, so that you have automatic access outwards, but then the variables you define in your Terraform configuration will set up where the access is for inbound. So it's not going to be default 0000/0. I didn't want to do that out of the box. We need to create an internet gateway, of course, because we've got private subnets, so we need to make sure they can access the rest of the earth. We needed to create a routing table with subnet associations. I'm actually going to blog on this one just alone because this actually was a fairly tricky thing because in Terraform, your subnet association depends on number one, the routing table, the VPC, and the subnets, none of which exist. So we had to actually completely dynamically discover this. But this fantastic thing about Terraform in this case is it builds this all for you, understands the dependencies, and we've actually set some hard dependencies. So we'll take a look at that in the code. First, we create an EKS cluster. This is actually surprisingly the longest part of it because it's actually got to set up naming services, everything in the namespace definition, because you have to have internal name services. So AWS has its own little wheels spinning. Well, it's making sure that its own name resolution is clear because it has to use FQDNs based on the internal names. So they have to sort of wait that out, make sure that it's all replying for the internal service registration. And then we're going to assign an EKS node group. In this case, by default, I've set it as a single node, maximum 3, but you can adjust that all with variables. So it's super cool. All righty, so here's a table which tells you exactly what the variables are that you're going to need. You need an access key. This means it's just your AWS key so that you can access with programmatic credentials. Your secret. Now, these are sensitive in that they're going to be stored in your Terraform Cloud configuration. So you're not even going to need to worry about people seeing them or people using them. They can't extract them, and I'll show you that. The region you're going to launch in. As a longtime fan of radio, I'd always like to spin my stuff up right next to WKRP. So it's actually going to go in US East 2 because I'm a fan. So shout out to Cincinnati and the Ohio folks there. AWS key name. So you've got an SSH key. This is for accessing your Kubernetes nodes after the fact, once they're spun up, because you may need to actually do additional work in there. Luckily, you don't often need to do that, but set up your SSH key just in case. Your fingerprint. So this is a hex code fingerprint that's pulled in from AWS. I've got a certificate here, and it's actually not necessary in the default configuration. So I should mark that, and I reminded myself of that just now. Allowed IP networks. This is HashiCorp Configuration Language, or HCL. So we're going to use a format which basically just looks like a simple array, and you're going to set which networks are allowed to access. This could be your own external firewall, your own internal network in AWS from another VPC if you're using VPC peering, whatever it's going to be. Your node min, your node max, and your node desired. So minimum is the lowest possible, which has got to be at least 1. Your max, what's the upper bound that you want to have? So in the case I'm on the view you're going to see, I'm going to use 3. And then we're going to set the desired. So we want it to always be the desired. And I've actually set that to 1. So whenever possible, we want to try and consolidate down or reduce the node count where we can. So that's the variable configuration. Let's go take a look at what it looks like now inside Terraform. Okay, so now what I've got is I'm going to open up. You can see we're running away in the background. We'll walk through that as it spins up. We're 9 minutes in. We're doing pretty good. I haven't had to click anything yet, so it's pretty fantastic. Our variable definition, like I mentioned before and showed you. So our access and our secret key are sensitive. So that means that you put them into Terraform and you can only write there. You can't edit, you can't pull it out. You can only write a new value. This is great because then I can give rights to this particular configuration in Terraform, and then you have access to the credentials that I provide. If I nullify those credentials or nullify your access to the Terraform cloud configuration, that's it, free and clear. And so I know that I've got the best way to manage in case we need to change people around and change credentials. Ideally, we could go a bit further and use like a vault or use AWS Secrets Manager, but I wanted to do it and leverage the secret capabilities which are baked into Terraform. We've set our region, like I said, US East 2, just a simple text. Let me zoom in a bit, a little bit easier to read there. The key name. So I've already uploaded my SSH key, which is a requirement as a precursor. I know what the fingerprint is. I've got my certificate ARN, so that I know that's the way that it's going to be referenced by any code. My allowed IP networks, I've got this kind of wide open, and also I've got a couple of internal networks. So all you have to do is make sure it's surrounded by square brackets, if that's the sign for square brackets, I don't know. And then each one needs to be quoted inside. So effectively, it looks like an array. And then you have to set this. You'll notice the type here is HCL, because if you just put this as a regular value, it won't parse it correctly. So you have to set it as HCL. And EKS role. So I've got to have a role that I'm going to set up. I've got to have my minimums, my maximums, and my desired. Now, the cool thing was this was the role that I defined originally, and I don't even need this anymore because I'm completely dynamically doing this. So back up 2 minutes and forget that I said this, right? So the role and the certificate are not even necessary as we go ahead. All right. Now let's whip back and let's see how things are going. Oh, that's a record. There you go. 11 minutes in and it's done. So we're going to check our students' work here and see how they did. The plan, let's quickly look at what the plan is. And wow, there's a bit of an eye chart here. So let's take a look at this. Now, so I'll apologize for the vertigo here. Let's just take a look at it. So the way that your Terraform works is that it takes your code repository, which I've set up. So I've already created my, and this will be in the white paper. So if you want to check that out, drop me an email, hit me up on Twitter, hit me with a DM, and I'll make sure that you get access. We'll post it up on the Turbonomic blog. This is part of the open source side with our Turbonomic Labs, which is kind of cool. So I'm using Terraform 13.5, latest and greatest. And what I'm going to do is it runs a plan. So I've got a version control system as the back. I've set my variables, and now it's going to run a plan. It confirms everything is completely self-encapsulated and maintained here. It's going to go through, look at all the different resources. It builds this. It looks for the dependencies. And then it's going to go ahead all the way down a lot of different stuff that gets built. And what do we get in the end? Ooh-wee. It's going to tell me it has 25 resources to add. and then 0 to change, because this was completely built from ground up. You can actually modify it after the fact. That's the cool thing. If I wanted to change the node size, it does it safely within the EKS infrastructure. And then, of course, it's going to run. You saw here, it takes about 11 minutes. And then the end result is it gives me my endpoint address, and it gives me my my certificate authority, which I'm going to need in order to configure to access it. Now, let's pop over and take a look in AWS. So I've got my VPC, which I've created. There we go. There's my EKS VPC. Let's take a look at my subnets. I've got all 6 of my subnets here. Sorry, zoom in a bit. So I've got my internals, my externals, and then inside there, I've also got my security groups, which I've tagged everything to make sure that we know what's what, just in case we want to leave it running for a while. I've set a couple tags. So if you take a look here, here's my inbounds and my outbounds. Now this is cool, right? Like I defined all my allowed IP ranges, so it did all this for me. I didn't need to individually assign it, which is very, very nice. And again, tag everything, tag everything. You notice I said Turbonomic true in here. It's because I'm actually going to then target this with Turbonomic after the fact, which is also pretty cool. We'll save that for a Tuesday show. And then from there, we've got our routing table. So we've got a specific routing table. We've automatically brought in the 6 subnets that are assigned to it. So we've got that associated. This was where the little bit of care and feeding was required, and we're going to whip through the code, and you can see what's cool about this. And like I said, it's open source code, so you can download it and pull it anywhere you want today. Let's go over. So this was at the start. I launched my console here, so I'm going to hit refresh, and there it is, EKS Lab. So I've got it. It's set to 117 right now, which was a configuration parameter that I built. We can adjust that, of course. We've got my certificate authority, my connect URL, my API endpoint. Don't worry, you can look at this. It's all going to be gone by the time you can log into it. Plus, you don't have the right credentials anyways, so it's safe to post this one on the internets. Under compute, now I've also built my NodeGroup, which is set for, it created my autoscaler for me automatically. It assigned me the different subnets that I've got. We have a choice to set Kubernetes labels. I haven't done that yet as part of it. We have all the different tags and update history. And so then the last thing we're going to look at here. Yeah, so your networking. So we've got our subnet. So we've right now got it set for the 3 publics and our cluster security group. Now, the reason why I want to talk about seeing this, how it went, was for you to set this up. It's not difficult, but it's a number of steps that have order dependence. So I need to have my roles set. If I wanted to go ahead and set a brand new one up, then I've got to go create my cluster. So when I say create my cluster, I choose my version, choose my service role. Then I'm going to set my tags. So I have to go through. Let's do this. I have one here. I've got to set my subnets, and you'd say, oh, darn it, I don't have subnets. I want to create a VPC. So I've got to create another VPC. So I've got to, you effectively, as you do this, you have to go and backfill all of this information. You have to find your security groups. You have to be able to set which ones you want. You need to be able to set your IP range. You want to set whether you're public or private endpoint. So you're going through all of these different configuration settings. And assuming you had everything that was a prerequisite, then it takes about 15, 20 minutes to set up, and then you can add your compute cluster to it. So which is another wizard you got to go through. So doing it programmatically is incredibly valuable because it literally was 11 minutes from start to finish. Okay, so just quickly look through. In fact, it's hard to look on here because I know folks like a darker dark mode here. So let's zoom this in a bit. Let's take a look at what the code looks like. So our variables are defined, and the way that I've broken the code out here is I've identified each file name by a functional set of criteria. This is totally your mileage may vary and your preferences will live in you. If you choose to make it all as one file, you can do so. Remember, Terraform packs all of these files together and then evaluates them as a complete set. So everything with a .tf will get evaluated. It looks for the dependencies, looks for the where it needs to go, and then what it does is it then runs the plan against the collective of all of these files in the appropriate order. It's actually fantastic because for a loose programmer like me, I don't have to be so strict about it. So I, by my choice, decided to identify that this is my variables. Then I'm going to set up my provider, which I'm setting up my VPC or my AWS configuration, which is all variable based, and then my Terraform configuration. Now, this one can't be a variable, sadly, because it's a dependency, because you can't have a variable in Terraform Cloud when you can't see Terraform Cloud. So you will have to fork the repository or clone it and then live with the differentials. So I have actually put this in there because I needed to for the purposes of what I was doing. So I could actually clean that out. I'm not a programmer. You'll get to find out when you read some of my code. So now that I've got my provider and my variables, oh, and one thing about the variables, this is actually cool. We're going to use something called a map. So what I'm doing is I'm saying that I'm going to give a map where you say if value A, then give it, or key A, then give it a value B. So in this case, I'm just saying 0, 1, 2 is equal to ABC. And you're going to see why, because I wanted to set up my distribution of subnets across multiple availability zones. And the only way that I could do that was to either name the availability zones. I thought, how can I do this where I can say that if I go through a loop? So what I did was I said, I'm going to go in whatever the name of the VPC is, or what the region is, and then just tack on A, B, C, because there's an A, B, C in every single region that I'm going to go in with EKS. In fact, there's a D for almost all of them. So as we look at the code, you'll see that it now automatically distributes both my private and public subnets across multiple availability zones. So not only is it a completely automated lab, but it's completely resilient as well, which is kind of cool. Okay, so first up, we're going to start with our VPC. Now we take a look at our VPC. Very simple, not a lot of configuration that's needed. The overall CIDR, so this is going to be the default configuration. It's a 10.0/16. Default tenancy, so this is standard shared tenancy, not using classic link. I'm allowing DNS support, which is an advantage so that we can use everything by FQDN, even though they're internal names. Allow for DNS host names, so that's both internal and external. And I set my tags. This is one tag that's required for EKS. You want to make sure that ideally everything you have has to have this tag about being able to be part of the Kubernetes infrastructure. So I'm setting this throughout. This is also when you set it up by hand, you figure out the hard way that this stuff doesn't happen on its own. So I've got my VPC. Next thing, I'm going to have my security groups. Remember that we said I want my egress, so everything should be able to access the internet so that it can pull updates, pull containers, and access the earth for security updates and such. That's egress, so that's going outbound. However, the ingress, I didn't want to hard code it here. So what I've done is I've said I'm going to do var allowed IP network. And because this is crafted up in HCL in my variable, it's going to automatically pull in all of the networks and allow them all, which is, we saw it actually in the console. So that's going to be setting up for SSH, for port 80, and for 443. If I really wanted to get crafty, I could have a separate one for port 22. So it's up to you. This is meant to be a lab, so you stand it up and tear it down over time. Now that we've got our security group, the next thing we want to set up is our subnets. Now this is where we're going to do a little bit of fun logic, and we're going to just quickly walk through it. Alrighty, so what I've done. So I'm using the count inside Terraform. So this means that it automatically knows to loop on a count 3 times. And because it's a programming thing, it goes 0, 1, 2. So whenever you're naming things, make sure you always go 0, 1, 2. It's not 1, 2, 3. I'm an old ops kid, so I count by 1 and up. But for programming in an array, it always starts as element 0. So we've got, that would be a good name for a band. So count 3 is going to go 0, 1, 2, and then I'm going to have from that point, everything will have those names, because what I'm doing is I'm setting the CIDR block of this particular subnet according to the count. So it's going to be 10.0.0.0/24. So it's going to be a class C. The next one will be 10.0.1 and then 10.0.2. So we're going to have 3 class C networks, each based on the third octet according to the count. And then this is where the fun part comes in. So I'm going to take my region variable, which I've defined, and then I'm going to take my availability zone map, which I've defined as a variable. And then I'm going to take the count. And so I'm going to say US-East-2A for element 0, US-East-2B for element 1, and so on. So it's pretty cool, because this means that now you can actually use this kind of code elsewhere. So all you need to do is just concatenate the 2 variables, and it automatically then builds it as a string when it evaluates it. So that's very, very cool. Saves you a ton of time. Same thing, always tag everything you can so we can keep track of what's what. And I'm using it for, like, I set my Park My Cloud and my Turbonomic stuff that I use tags in order to capture things so I don't lose track of it. We have to define our Kubernetes that we're going to allow it to host an ELB. These are just tags that are required for EKS. That's my public subnet. So I've got 3 public, and then I'm going to do the same thing for private. And so this is going to be 10.0.10 and whatever that count variable is going to be. So the first one for element 0 will be 10.0.100, 10.0.101, 10.0.102. So that's just my preference of how I number my subnets. And then they're going to be, again, across those 3 availability zones. And then the same story for your tags. So now you've got your VPC, so your private, your security, you've got your ingress and egress groups, and now we set up our subnets. Now the fun part, we are going to now go, and this is where the real fun happened, because I needed to set up my subnet associations. Now remember, your subnets didn't exist. And if you try to just assume what they're going to be called by running a count variable, I say this from experience, I tried this, it didn't work. You can't have a count variable which has a dependency that doesn't exist yet. Pro tip, there you go, that's a Terraform pro tip. So what I've had to do was then go ahead and pull them in dynamically. So the first thing I set is I'm going to define my gateway. I need an internet gateway in order to speak to the rest of the world, because I'm creating these from the ground up. This is not a pre-existing VPC. Then I create my routing table. I don't want to use the default routing table. I want to have a specific routing table assigned to do all of the routing for this. Now I'm going to create my route table association for the private subnets. And let's take a look at how we do that. So the subnet ID is going to be based on the count index. So we're going 1, 2, 3. So we are going to use that .id. So this is going to actually programmatically go through in that. As we look at the different dependencies, it has to look for what's the subnet and then assign the routing table on it. So we already know the routing table is fixed. This is important because we have to say create before destroy, because what will happen is quite often if you rerun this or you want to do a destroy and it doesn't exist, it's going to freak out and it won't destroy because it'll fail. So we actually have to set lifecycle on this. This is a great parameter to use inside your Terraform, because some stuff orders very asynchronously. It uses eventual consistency. Now the depend is on. I require that I can't do this stuff until I have my subnets and until I have my routing table. This, again, very important. I needed my depends on because these have to exist before I can actually assign them based on the elements and the object IDs because the objects don't exist. And then I do the same thing for the public. So while this is a very small set of code, remember what this does is it looks for completely non-existent things and then dynamically discovers them and assigns them, which is pretty cool. So you can actually reuse this code block and this code style in a few different ways. And I definitely would recommend looking up how to use lifecycle and make sure you use depends on in ways that it's appropriate. You don't need it for everything, but this is a case where you do need it. The next step we're going to do is we create, oh, goodness gracious. I realized I missed one. I apologize. We needed to create our roles. So what I've done is I created this. This is why Terraform does it without me having to set the order because I'd have missed it. It will see this at the very start, and we're actually taking a policy, and I'm actually just writing the policy in. So we've got to have the assume role for EKS, and then I've got a different policy as well for the lab clusters for VPC and for the EC2 side. So what we're doing is we're taking all of these policies, creating a brand new role, and from that new role, which is going to be lab cluster role, so that I know what it is, I know where to find it, and I'm actually going to go ahead and be able to search this out based on that. So it's important that we want to set it up so that we can clean it up after the fact. So that's your role definitions. So our EKS cluster is the next hop here. So we've created our VPC, we've created our security groups, our networks, our subnets, our routing. So we have a fully functional public and private with 6 subnets, 3 public, 3 private, all the security groups configured, all the roles configured, 0 touch, literally 0 touch so far. So you're now the last part of the 0 touch. We walked through this in the wizard, right? I set my EKS lab. I dynamically assign my role, so I don't need it as a variable in the actual configuration. I pull in my subnet IDs, and I actually could add the private as well in this case. So if I want to do just private or private and public, now I want to make sure that I need those roles to exist first. So this is important because sometimes this may not go in the right order. So you set your dependency that the policy has to work and it has to be attached. So I've already built this. Otherwise, this is the other challenge. EKS can't do things inside. If you can't set the policy right, it can't create and destroy EC2 clusters. So that's required. And what do I want at the end? I need to be able to get my endpoint address and my certificate authority so that I can use this for the client. So now that is our EKS cluster. And then the final bit is we're going to build our node group. So our node group, we're going to set our cluster name, which is dynamic. It's discovered based on what we set before. We're going to define our node group name. You could technically use these as variables as well, if you so desired. I've set it for a very specific purpose, that this is kind of a build and throw away resource. So I'm going to define it a bit more statically than some may choose to. I'm going to go ahead and I'm going to concatenate all of the public and private subnets so that I make sure that it knows which available subnets it needs to be able to access and launch compute nodes into. Because if you don't do this, then you're in real trouble. Here, I'm setting my instance types, but what I can do is in the next iteration, I'm going to move this to a variable so that I can actually define it there. That's where it's even cooler, because now I have a completely dynamic scaling policy as far as whether it stays in the family or moves around. Scaling config, so I set my desired, my max, and my min, which we saw over in the variable configurations. This is the interesting thing here. Now, Terraform, as you may know, does continuous checks on Terraform Cloud or Terraform Enterprise. So if there's drift and I have it set to auto apply, if I scale my infrastructure, then Terraform's going to be angry and it's going to say, nah, you need to actually, there was 3, now there's 5. that's outside of the set of for desired size. I want to break that. Or I'm going to change my instance types. Right? How do you make sure that Terraform's not actively fighting against a dynamic environment? Also a hint, right? When I'm using Turbo, in my case, so Turbonomic, I'm dynamically scaling the containers and the nodes. So I don't want it fighting with my EKS configuration, and I don't want it fighting with my Terraform configuration. So now it stands up automatically, but it leaves the changes to be allowed to be dynamic. And then I set my policies as dependencies and making sure, because again, in this case, in order to set up the network interface for my load balancers, I needed to have this in place first. So I set my depends on and my policies. So it's been a lot. That's a lot of code. And if I looked at it, what are my total lines? Let's assume I've got an average of 25 lines. I've got, let's say, about 220 lines of code. So it took a couple of days to piece this together. But the advantage that I've got now, because I have done the hard yards, so you don't have to, all you got to do is go to the repository here, and I'll put a link up to the white paper when we actually post it, because that's going to be, I just got to finish up writing, and then I'm going to get my design team to fix it up really cool. And then we'll post that there. We'll have a copy of this in here as well. So if you're discovering this after the fact, it'll be kind of a cool inception, because you'll now see a YouTube embed here. So we'll have all the instruction set. And you're literally end-to-end, fully functional EKS. And this is where we do the Billy ways. But wait, there's more. What was the purpose of doing this with Terraform? If I wanted to have it be long-running infrastructure, I set my life cycle, and I set my life cycle ignores. Because if I want to run a long time, I have to assume there's going to be dynamic changes. If there's dynamic changes, Terraform will get angry. I don't want Terraform to get angry. I don't want AWS to get angry. I don't want to have other dynamic changes cause confusion in configuration drift. So we've set the appropriate dependencies, and we've set the appropriate lifecycle configuration to ignore changes. But even more importantly, I'm on a budget. My use cases, I wanted to stand up EKS. I want to deploy a bunch of stuff to it, kick the tires on it, try some different settings and configurations, and then I want to clean up after my pets. But I don't want to have launch group 248, right? I don't want to have all this dynamic junk left behind. So now I go ahead and I say destruction and deletion. You have to set this, so you have to say allow destroy. I say Terraform, EKS Lab. So I've done my work, and now I'm going to clean up. So it's going to go ahead, it's going to check against my configuration. Because I've got life cycle configuration settings, it will ignore changes. So if some stuff is a slight drift, then it will not be concerned. I do have to say this, that if you run it for a while and you set up internal load balancers, there is an oddity within AWS infrastructure. There you go, the plan's done. If you have new load balancers, and load balancers have ENIs attached, Elastic Network Interface, there may be an occasion where when Terraform is trying to tear down, after it's been up for like a few days and we've got multiple interfaces stood up, there may be a case where as it goes to try and remove it, that one takes too long for the dependency to be completed. So as it tries to tear down a bunch of network interfaces and a bunch of security groups, they have internal dependencies inside AWS. Terraform is smart enough to figure that out. However, the wait time sometimes isn't enough. And so there may be a rare occasion where when you're doing the teardown, and actually let's take a look at some previous runs, where, there we go. So here's an example. Queue to delete, and you'll see after a while, it got to this point where it says, it keeps trying to destroy my VPC. Well, it can't destroy the VPC because I have an active network interface attached to it. And the network interface is attached to a gateway. The gateway is there because it had an active load balancer. So you can see that kind of domino effect of dependencies that it couldn't complete in the time that it was allowed to wait. So under that 5-minute window, we have the option of either extending the wait time to say 30 minutes, or the alternative is that, look, let it set for 5 minutes and then just keep your eyes on it. You could set it to notify you in Slack or something. And then if there's a problem, then you know, hey, I got to go back and I will have to manually check. So I can go through and I'll check my VPC. And that's generally the first place to go is your top level. You'll look at the VPC, you try and manually delete it, and it'll say, hey, can't do it, kid, because there's a network interface attached. So you go to the network interface and you see what's going on there. And you may find that those dependencies can get resolved manually. So that's the only caveat that I got to give, is that I have found that there are occasions, and maybe I should set the timeout a little longer. Could be potential. That'd be a way to deal with it. But by default, it's 5 minutes for each resource, and 30 minutes for the overall. There's certain things that have longer triggers, like the EKS. I think the default is set to 30 minutes because it could take a while. I've actually had EKS alone, just setting up the cluster, take 30 or 22 minutes. No other change. It's just that's the variations you get. The whole thing took 11 minutes this time. The last time I ran it took 31. So your mileage may vary. Let's just quickly go back before we shut down for the day. So we've got so it's applying. It's in an applying state. So again, it's going through the different resources. You can watch the whole reverse teardown. And this is handy. So there you go. I hope that this is helpful for all of you, because I know from my own experience having to stand up these labs, and I use them internally at Turbo all the time, right? I need to quickly stand up a lab, do a bunch of things, and then I don't want to leave it behind running because it costs you to run those EKS nodes, the cluster. Just setting up an EKS cluster, even if there's no compute nodes attached to it, there is a price. I'm not going to quote prices because that's like they move, they change, and it's nothing against AWS. That's their function. They've made this broadly and commoditized the availability of it. However, some things have a persistent charge, like your internet gateway. So your VPC is free, but your internet gateway is not. If you've got elastic IP addresses, they're free if assigned to another running instance, but they're not if they're idle. So there are certain things that you have to look out for. So we know that you're going to run this, and you're hopefully aware that there are some basic costs to it. So this does not fall under the free tier, sadly, but there are things, at least if I wanted to do this, I can run it for a few hours, goof around with Kubernetes, and then tear it down. Because if I want to learn how to administer EKS, I shouldn't have to do this over and over again, stand it up manually and do these processes. And more than anything, this code base is handy because you can use this code for a variety of other resources in AWS, in Azure. So we could probably do the same thing. I'll probably do the same thing for AKS because it would be relatively similar code base, but different providers. So there's some idiosyncrasies around it. So that's it. Welcome to a completely dynamic, fully automated EKS lab using Terraform. And this is powered by my friends here at Turbonomic Labs. Let's see how they run. So look at that. It's going to take it. It'll take it as long to tear it down as it did to stood it up. But remember, what did we actually do to do this? Clone or fork the code, set up your cloud configuration, click plan, profit. You're now in the business of dynamic labs and infrastructure as code. If you have any questions about this or anything else, of course, you can always reach out. You can find me. I'm right there. You can find me on Twitter. My DMs are open if we're not already connected. Do also click on the subscribe buttons, the like buttons, wherever those things are. They're all over the place. You want to subscribe to the channel because we're doing a ton of great stuff with Turbonomic Labs. I've got a lot more new things that are coming up. If you're checking out some neat stuff with OpenShift, I'm gonna be pulling in my friend JJ and a lot of the team over in the IBM OpenShift and the Red Hat OpenShift folks. we want to do more with that because I've had a lot of demand. A lot of people are asking about that. So we are here. So again, always go to turbonomic.com/labs. Click on the office hours. You can see the schedule, and you'll see when the live events are coming up. And with that, we're done for the day. Big shout out to Elizabeth Sheehan, the best voice in webinar radio. She's making all this craziness happen. So thank you to all of my team at Turbo and to all of you for watching. I hope you enjoyed this. I hope you find value. Drop me an issue in the GitHub as well. If you got any questions, concerns, you want to add code, happy to accept pull requests. Fire up any issues, put it in the issue, and we'll take